Yeah, my name is Wei Jie, and I'm actually the study lead for ammonia bunkering safety in GCMD, which is the Global Center for Maritime Decarbonization. So what I'm going to do next, within the next 15 minutes, 13 minutes actually, is to sort of summarize what we have done over the past 9 months, which is actually compiled into a 250-page report in over 10 minutes, and give you a high-level appreciation of what's going on, and also tell you where you can find the actual report. So a bit of background about this. Back in 2021, when we were first founded, we decided, why not we do ammonia bunkering as our first project? And we think that it's a very good pilot because we know of consortiums that are looking at ammonia transfers, looking at building ammonia ships, looking at building ammonia design engines. But what we found that is missing are actually all listed here. There are no projections for ammonia bunker demand, so we don't know what sort of capacity we're looking at. We don't have a technical reference for ammonia bunkering. We got no competency framework to support training for ammonia bunkering exercises. There are no sites in Singapore that allows us to do ammonia bunkering. We have no appreciation of the capex required for these sites. There is no risk identification or assessment for the different concepts that's possible. There is no guidelines for transfer to assure quality and quantity. And there are no regulatory guidelines for sandboxing to conduct a pilot. And this is the reason why we brought together with us, 22 study partners across the entire supply chain to teach us and guide us and contribute towards this study together with us and the consortium comprising of DNV, Sabana Jurong, and Singapore Maritime Academy to develop the whole exercise with us. In addition, there are 130 industry consultation and alignment panel members who contributed towards the study by giving their inputs, feedback on how things can be done. In fact, we actually are still revising the report as we go along to make sure that it incorporates as much comments as we can. So one of the first findings that we have, and we start from capacity building, is because it's actually a very important part in terms of doing modeling, in terms of understanding which sites are possible. So this is the first thing that we did, and our finding is that ammonia bunker demand is expected to take up in about mid-2030s, looking at about 2 million tons per annum. It can be supported by 1,005 cubic meter bunker vessel. Some of the projects that are ongoing, and I'm showing here, is Project Sabre, for example. They are expected to commence in late 2050, in the late part of this decade. We know that commercial bunkering infrastructure have to FID sometime in about 2030. Commercial bunkering infrastructure then has to be ready at about post-2030s. And in more recent terms, we know of other announced projects. For example, Emergy's tugboat is actually undergoing retrofit, FFI as well. And we know the first Wasilla engine for the four-stroke is actually expected to be ready within this year or next year. We know our friends at NYK is getting ready to retrofit their tug this year and next year for operations. We know MAN has already announced that their engine is going to be delivered within the next 1 or 2 years as well. And NYK and other consortiums are looking at larger vessels for ammonia, for the use of ammonia as a marine fuel. So in terms of site selection, we did a very comprehensive site selection comprising of 43 criteria across 6 areas: marine, health, safety and environment and demography, constructability, additional capex, accessibility, and land. So all these were taken into consideration when we talk about the site selection. We started off with about 20 plus sites. We shortlisted to 7 sites. And from these 7 sites, we actually identified 2 sites that has the most potential with minimal investments for us to do our pilots. One of the sites, unfortunately, is not being ranked, and you'll see site E. It's more because of it does actually score very highly. There's some considerations in terms of accessibility, and therefore it's actually not being ranked. In addition, we have also done a study, and we believe that Raffles Reserve Anchorage can be actually one of the first sites where we can do our pilots. So what does this mean in terms of concept? Firstly, we believe that Terminal A, one of the 2 sites selected, can actually do a cross-dock break bulk. In terms of the flow rate, we actually are looking at 1,500 cubic meters per hour over 2 pipelines. We think that Terminal D can actually be looking at shore-to-ship bunkering at a lower flow rate, more for nearer short sea vessels. And for Raffles Reserve Anchorage, we think that it can actually handle 2 types of concepts, both the break bulking and bunkering. And flow rates of different configurations were also assessed. In terms of capex, what we mean by investment cost is actually listed down here. So this model will also be available for download in terms of giving people a high-level assessment of what's the capex cost going to be like. So for example, at Terminal A, when we talk about cross-dock transfer, We expect the investment to be about 14 million, and that is really a high-level estimate, which will then need to go into the site details itself when we talk about detailed engineering. For the shore-to-ship bunkering, given the low flow rate and existing infrastructure available, we think that you can actually start your first pilot at about 2.5 million. We then did a hazard assessment. So there was a workshop that was done across all the different configurations at the specific sites. We believe that most of the, all in fact, of the risks identified can actually be mitigatable. So what that means is, from a risk perspective, going ahead with a pilot for us is actually possible. So just now we heard a bit about risk and safety, and that is actually very important for us, right? So in terms of risk assessment, two ways was actually used for us to define the safety zone, and that is because of the nature of the regulations and of the sites itself. For example, Terminal A and D, both are on land-based, so you have to apply the land-based QRA requirements, and therefore their risk is actually, and safety zone is actually determined based on the probabilistic model. Next, we realized that there is actually no guideline in terms of how we can define the risk or the safety contours for ship-to-ship transfer at the anchorage. So what we did was actually to take elements of the QRA guidelines and also understand the principles behind TR56, which is the technical reference for bunkering, to understand how we can actually quantify risk. And I'll show you a bit of the results and why we think it's important to look at the different approaches. So if you look at two approaches that we use to determine risk and different safety zone, if you take a probabilistic approach, and given that we're looking at bunkering pilots, you will find that because of the frequency, the probabilities are actually very low, and that means you actually have a very low safety zone. But is that practical for your first pilot? Maybe not. And you look at the deterministic approach, which is what we've been talking about. It is actually about 320 meters. And what this means is that it's actually perhaps a more credible approach to start with, before you look at using the principle of as low as reasonably possible to sort of narrow down your risk and look at what are some of the practicalities that you need to take into consideration. Is it considered high? Maybe not. The reason why we say that is because we understand when LNG first started, the zones we're looking at is about 500 meters. So what we say is, perhaps going ahead with a pilot is quite a feasible exercise. And so what are some of the learnings that we have? We are going to use a deterministic approach in terms of scoping out our pilot and the safety zones required. We want to mitigate risk by two ways. First is to really reduce the inventory transfer, and of course the duration. And both are really the factors that affect the risk. We want to operate at flow rates close to design specification, and that is really because two-phase flow can actually increase the amount that's being dispersed, and therefore increase your safety zone. So what we want to do is really to maintain it at a single liquid flow for the purpose of the pilots. We want to tap on experienced personnel, and what does it mean is people who have worked on gas carriers to really support us in that project, so that we are actually working with people that are confident and are aware of the risk of ammonia. We think that emergency shutdown systems will be part of the solution, and also emergency release couplings to reduce reaction time, and at strategic locations to really minimize the inventory losses. There are other precautionary measures, and just now Liu Ming has also mentioned about mitigation measures, and all this will play a part in terms of us designing the actual pilot. Integrating water condoms may be good for small leaks. We are a bit unsure about its effect on larger leaks. And of course, all personnel involved with the pilot should be wearing appropriate PPE, as always. So what does it mean again? And there's a lot of pieces out there. We want to generalize the learnings that we had to develop a guidebook to help us push forward to develop the technical references for bunkering. We need continuous dialogue with the regulators because ultimately whether we can succeed or not depends a lot on the approvals. We want to articulate training curriculum to help build up manpower capability so that we can actually do our first transfer, second, and of course the third transfers. We want to help shape standards, both domestically and internationally. And lastly, something very important for us, we need to develop emergency procedures. And of course, to conduct it through a proxy pilot to build confidence. So some of the things that are already being done or are going to be done. Firstly, we have already developed a guidebook, so this is something that is already done. There are 4 parts to it, and you will definitely have a copy of it by the end of the day. So one of the first things that's been done, part of our work has already been incorporated into Singapore Maritime Academy's training curriculum. The first course was actually commenced in March, and the second course is actually starting in June. Next, we want to help shape standards. And what this means is we are actually going to approach the standards development organizations in Singapore to really share with them what we have done, and hope that it can actually help to build the first step towards building the proper technical references for ammonia bunkering. We want to participate in workshops, in working groups, to help us share our findings and help build better confidence in the whole process. We want to talk to, we have already initiated conversations with the likes of SIGTO, OCMINF, and SGMF to really see how we can share with them our results and work together to really develop standards for ammonia transfers. So what we want to do in practical sense, and that's what is the theme of today for SMW, when ambition meets action, right? We want to aim for the transferring of the first drop of ammonia by the end of this year, subject to regulatory approval. And we know it's not going to be easy. We are actually currently scoping the ammonia pilot, taking Singapore as our case, more because if you want to go down this path, you need to develop a detailed QRA, HAZI, and HAZOP, right? And that's point number 3. We have identified 2 ammonia vessels that can actually help us to do this transfer. We will mimic the break bulk and bunkering, but just as a highlight, we are actually going to do a ship-to-ship cargo transfer because there's no fuel tanks available and there is no engine available. But we think that it's actually a good step to help us build confidence from a regulatory perspective, from an emergency response perspective. Ongoing conversations are important, so we are actually engaging with the different regulators to really build our confidence, understand what needs to be addressed. We are currently speaking with OSRL to really develop emergency response procedures, and this is really going to be shared with public in our second phase as well. There are also ongoing discussions in terms of cargo integrity assurance. What does it mean to transfer ammonia? How do we take care of the losses? And we think that we can do this by taking the learning by doing approach. And we believe that this exercise or this pilot across 2 cargo tanks will help us build better confidence here in Singapore and the ecosystem before we move to an actual ammonia bunkering pilot. So now, what does it mean? The report is out, right? So by scanning this QR code, you'll go to the page itself. It's a 250 page, bear with us, I've read it at least 10, 20 times. So next, this is also the team that has been working on the report, and there's definitely a lot of people who are behind us, supporting us, and we're really thankful for them. Similarly, as our other speakers, we're looking for partners to join us in this journey. I'll be happy to stay behind and speak to anyone who's interested, or to find out more that I cannot share, right? So with that, I hope you all had a pleasant lunch, and thank you very much.